Hey guys, it's Dr. Conklin. I'm on Página 11, page 11, and we're going to do some review of a bunch of different Regents questions today. So I'm going to pause, fill out questions in our Ed puzzle, and we're just going to do, I think there's 8 of them total, so we got this. I still don't know how to play music when I have my screen shared like this, so again, somebody email me and tell me, and then I could have music for you guys. Okay, so these are what I like to call number 1 and number 2. These are $100 questions. What do I mean by that? Well, some of you may know that when I was in grad school, I loved learning actually about the mathematics behind gambling. So card counting, all that number theory, it's actually a really important part of mathematics. So I always find this interesting. So I call these kind of questions, number 1 and 2, $100 questions. I will give each of you $100 if this is not on our Regents exam, a question of this topic. Now, I'm not a dumb lady. So what does that mean? There's going to be a question like one of these on our Regents if we have a Regents this year. So let's go through and talk about it. If I have a line y equals 2x minus 4, and we're going to dilate by a scale factor of 3/2, what's going to happen? Well, I'm going to keep the slope the same. We know that lines that are dilated have the same slope. But I'm going to take and multiply our b value, which is -4, times 3/2. When I do that, just a reminder of how to do that multiplication, 2 goes into 4 twice, so -2 times 3 is -6. So our answer here is going to be B. Okay, let's look at number 2. Okay, same idea. Now this is a little bit harder because we have to do first some solving. I got to get y by itself. So I'm going to take away 2x on both sides. Y equals -2x plus 1. So first of all, before I do any kind of solving, I'm going to use cross elimination here. My slope is -2. I have a scale factor of 4 with respect to the origin. So I only want a slope of -2 for our answer. So I'm actually going to get rid of C and D. Great strategy. Now, in order to get the scale factor, I'm going to look at our b value, which is 1, and I'm going to do 1 times our scale factor of 4, which gives me 4. So our b should be 4, our m should be -2. The only one that fits with that is choice B again. Okay, so give yourself in your head like a little check. Would you get $100? Well, like I said, it's going to be on the Regents, but how did you do on those questions? Because those are ones that we almost guarantee will be on the midterm and on the final, okay? Now, let's look at these. We have a triangle ABC, and I'm just going to sketch it out so we can look at it, and it's dilated by a scale factor of 3. What is true of the image A prime, B prime, C prime? So I'm just going to copy this and paste it. And when we're dilating by a factor of 3, what are we doing? We're making it 3 times as big. So I don't know if I can make it exactly 3. I'm just estimating here, guys. And I'm going to put on my little doop, doop. Oops. I lost the C. What do I know is true? Well, here's one way to sort of help you with this. If you notice A and B are talking about sides, C and D are talking about angles. So which of the following has to be true? What I'm going to do is just pick a side and pretend that this side is 3. Let's pretend these are equilateral triangles. If I make something 3 times as big, this is going to turn into 9. So let's see which is true. So if I read choice A to start, 3 times A prime B prime, so what's the length of A prime B prime? So 3 times 9 should equal the length of AB, which is 3. Is that true, guys? Does 27 equal 3? No. So it's not that one. Let's try this one. Again, I'm going to just sort of try to color along so you guys can see what I'm doing. B prime C prime is 9. Does 9 equal 3 times BC? Where's BC? Ooh, that's 3. Is this true, my loves? Yeah, this is the one that's going to end up working. Let's talk about why the others are not going to work. Angle measurement in triangles in dilated triangles is preserved, meaning that all these angles, it doesn't matter if I make them smaller, bigger, dilate by any different factor, they're all going to stay the same. So triangle angle measurements, I might have just messed up that, how I said it. Well, I'll put a little note in for you guys in the Edpuzzle. But the angle measurements are preserved when we dilate shapes. Okay? All right, so let's look at this one here. Now we have a graph. And this, oh my gosh, I remember when this was on the Regents, my students did not do super great on it because the wording is so tricky. So let's really take our time and go over it together, guys. In the diagram below, CD is the image of AB after dilation of scale factor K. So this is the second line. This is the first one, meaning, well, line segment, just to be mathematically precise. This is our pre-image. So this, actually, if you think about this, guys, this is shrinking in size. So we're getting smaller, closer to E. Which ratio is equal to the scale factor K of the dilation? So let's look through. E to C is here. That's a small number. And E to A is this large number. So if we compare, we're comparing small to large. So that one actually looks pretty good. Because in order for this to be a scale factor, we want to shrink. A shrink means we have a fraction, like 1/3 or 1/4, right? Now if I look at this one, and I'm going to compare the sides here, B to A and E to A.
Mom, I don't know how to get to the yesterday one because I didn't do the PE.
Oh, you want to do it now?
Yeah.
Charlotte's cousin caught the fish in a web.
Is that from yesterday?
Mm-hmm.
No.
There you go. It's down there at the bottom, honey.
No.
So if you look at this part, guys, E to A and B to A are not even really related to each other. E to A is how far it's gone, and B to A is the length of it, of one of the segments. So it's definitely not that one. Let's take this question. E to A, and we're going to compare that to B to A. E to A, B to A. So that's the same thing, but reversed. Again, that's just comparing length of a length of distance to a segment, which doesn't really make sense again. And then the last one we're going to compare would be E to A and E to C. So this actually does show us how the line has moved. But do you notice how E to A is the larger distance? It's the larger length, and this is a smaller one. That would actually tell us we had something like a stretch, right? That D to C may be stretched to A to B, but it's the other way around. So our answer here is A. Super hard, 5-star tricky question. Okay, this one here I want you guys to give a try. Start by solving for y. Okay, so I'm going to solve for y just to show you guys what I would do. Okay, so if we look at this, we want to keep the slope the same. Now, when you're solving, do you notice, guys, how all these are written this way? We want to have the same slope. So what I'm going to do is I'm solving here for y, but I also want to take a second and solve in a different way so that I can make my equation look like our answers. So does everyone see here what I'm going to do is I'm actually going to move the x over. It doesn't happen very often that we do the opposite of getting y by itself, but let's do that. Oh, sorry, not -8, +8. So first thing we want to do is we want to have an equation that sort of looks like this at the beginning. So let me get rid of this 8. We want it to look like this part. Does anyone else see where there's 2x plus 3 anywhere else? No, I see lots of negatives. So guess what? Guess what our answer is going to be, guys? The only one that works is going to be choice A, because they have the same exact slope. Okay, I'm actually going to have us skip 7 right now because we're going to cover that tomorrow. Let's look at number 6 though. And first of all, this is just like an evil question because there's so many words, right? A triangle is dilated by a scale factor of 3. So if I had a triangle, I made a new one. If I'm dilating it 3, I'm making it 3 times as big. And it's being dilated at the origin. Which statement is true? The area of the image is 9 times the area of the original triangle. I'm not sure. The perimeter is 9 times the perimeter. Well, we'd have to figure out the perimeter, but that's really not hard. Let's do that before we're at the area. This perimeter would be 3 plus 3 plus 3 is 9. This one would be 27. Is 9 3 times 20? Let me say it again. To get from 9 to 27, I don't need to multiply by 9. I need to multiply by 3. So that's not the answer. The slope of any side of the image is 3 times the slope. Well, we know that the slopes of dilated lines stay the same. So it's not going to be that one. And then D, the measure of each angle in the image is 3 times. Hold up, we just talked about that. In a dilation, the angles stay the same, so it's not going to be D. So let's actually take a peek at this one, and I'm going to just blow this up a little bit to explain it more. How do we find the area of a triangle? A equals 1/2 base times height. So if I look at this question, and then if I look at this question, how am I going to actually figure out what the area is? Well, the part that's tricky about this is that we actually would have to go through and find the height of this shape. But if we look at this, this height is getting 3 times as big. This is also getting 3 times as big. So let's just pretend this isn't going to be mathematically correct, but this is x. And this is going to be 3x, right? So if I went ahead and did that, 1/2, the base is 3, right? And the height, we said, is x. My area would be 3/2 x, right? If I did the same thing here, my base is 9. Oops. My base is 9 and my height is 3x. Everyone with me? I'd have 27/2 x. So compare and contrast these numbers, my friend. 3/2 with 27/2. How do I get from 3/2 to 27? Well, we think the answer might be 9. So let me do 3/2 times 9. All right, and let me math frac that. 27/2. So that's the answer. So there's really 2 ways to get this question, my friends. You could either go ahead and eliminate the choices, or I know it sort of stinks, go through and do all this work. And I'm sorry, I got a little smushed. So last one we'll try together. This one is the one we covered on page 10. We have a line, y equals 3x minus 1. It's dilated by a scale factor of 2, centered at 3, 8. When you see it centered at a point, not the origin, there should be like blinding lights going off in your head. Because that means, guess what? This point is probably on this line. But how do we check? Let's go to our graphing calculator. I'm going to hit y equals, clear out what I have. I'm going to type in 3x minus 1, second table. Let's see. Is 3, 8? Oh, no, it isn't. It is on that line. What does that mean? If I have a line, y equals 3x minus 1, okay? and I dilate if I dilate by a scale factor of 2 through that point, the only thing it's going to do is try to make the line longer. But a line already goes on forever. So our answer is D. Do you guys see? This is a tricky, sneaky question, but we got it. All right, I hope you have a super day. I think we're just going to ask you to hand in a picture. Don't worry about 7, just because we're going to cover that more next week. Oh, you know what? One thing I do want to just go over. Do we have any graph paper that I added in here? I don't think I did. Oh, my battery is low. This is just how it goes some days, guys. That's just the way it is. Things will never be the same. You know what? I think I'm just going to end the video with one little quick review. If I had a point, let's say I had a line, okay? Okay, and these points were 4, -2, and 5, -3. And I asked you guys to do something. I asked you to dilate it through the origin by a factor of 2. Actually, no, let me start again. Let's say, guys, I had a segment XY, and X had the point 4, -2, and Y was the point -3, 6. All right? And I asked you to do something with that. I asked you to dilate it about the origin by a factor of 2, and then reflect over the line, let's say Y equals X. What would you do? Well, how are you going to dilate by a factor of 2? All we're going to do is take each point and multiply by 2. Okay, so X prime is going to turn into 8, -4. Y prime is going to turn into -6, 12. And then we know this little r means to reflect about the line Y equals X. You could certainly plot these points, my loves, and then just reflect them over the line Y equals X. But there's also a trick. I always remember that X comes before Y in the alphabet. So what we're really doing is just flipperooing them. So X double prime would turn into -4, 8, and Y double prime would turn into 12, -6. So if we were maybe to ask you a quiz question, wink, wink, or something else that asked something like this, remember, just do your dilation by multiplying each X and Y value, and then just do a reflection, rotation, translation, whatever it is, from those points that you've dilated. Okay? Have a great day. Thanks for all your hard work, guys. Keep up the good work. Almost a break. Bye.